All right. It's nice to be here. It's been a while since I've been part of the Institute of Design community, and it feels like home always. Years ago, I was here teaching a course on design policy, so it's sort of interesting to see how much data now has become foremost and center in everything we do. And I think that's part of what we want to talk a little bit about, its implications, picking up after the first panel. You know, one of the things that I learned and appreciated most about what happens at the Institute of Design is their focus on systems thinking. And if you don't have an awareness of systems thinking, I just wanted to help you understand that whatever level of analysis you're doing and your focus, there's always parts and there's always interrelationships that may or may not be obvious or visible, and yet they still have influence on what you're doing in the system. And that thinking itself is very obvious when it comes to dealing with the world that we're living in now that is so digitized and automated in ways that we're not very conscious of how all of those parts are operating. So in the digital environment, particularly, as we heard in the first panel, there are parts and there's processes that operate at really high speed, and they assert great power and alter the landscape, that, as well as how humans behave within that environment. And so today with our panelists, we're going to actually start to talk about how in their own organizations they're consciously evaluating different things at different levels and also applying some of these new tools and their interrelated effects. So I'm going to ask the panelists to introduce themselves and tell us a little bit about the organization you work for and your background, just so that they can appreciate your point of view as we continue the conversation.
Sure. Hi, my name is Reid, and I am a senior advisor of social and behavioral insights, that's a mouthful, at the Ontario Securities Commission. What the heck is that? Ultimately, we're the regulatory body that regulates the Toronto Stock Exchange. So I work for a regulator. I come at this conversation and all conversations with a sociological imagination. So I'm a sociologist by training. And mostly I'm interested in what are the sociological implications of what, who, and how we design things. I think that's particularly important in the context of algorithms and sort of both what is the data and what is the design of those things, both as inputs and outputs to human decision making.
Hi everybody, I'm Mark Burrell. I'm the, whoops, there goes my water. I'm the design director at IBM Watson Health, and I won't tell you the log cabin story, but actually I trained and I worked as a clinical psychologist, and a little nerdy fact about that is that my minors in graduate school were cognitive psychology and philosophy of science, or epistemology, depending on who I was talking to. So I was always interested in how people discovered things, how people changed, how knowledge grows both individually and collectively. But I actually practiced for about 15 years, and then many years ago, a couple of decades ago, that's how old I am, I started working in digital technology, trying to figure out how to use digital technology and information to promote human learning, human growth, human change. Sometimes to sell stuff, but at this stage of my career, I tell people that I'm a bleeding heart clinical psychologist. So the two things I care most about professionally are human discovery and human well-being, and so at least the mission of Watson Health is a good mission for me. So frankly, I feel like I've been working at this intersection for a long time, even though I didn't know it. So that's me.
Good morning, everyone. I'm Florent Buisson. I lead the behavioral science team at Allstate Insurance. My background was originally, I did a bachelor in philosophy, so still, we're not that, we still all have kind of a path on the human, a foot on the human side, I guess. So after that, I did a PhD in behavioral economics, took a long detour through strategy consulting and predictive analytics, and now I'm back to behavioral economics at Allstate. And so I work within the data discovery and decision science department. and I help the organization to a large extent to craft our messaging and our systems and how should we communicate information to our customers, how should we communicate information to our agents and our employees. And to finish, I have no fewer than 3 disclaimers. I'll go very fast. So a legal one, a technical one, a linguistic one. The legal one is predictably that everything I might say today represent my views and not those of Allstate Insurance. The technical disclaimer is that the department I work in, data discovery and decision science, does predictive analytic but not pricing. So I will be able to talk about the algorithm that we use to determine if someone is going to leave Allstate or sign up or anything, but I can't really talk about the pricing, the algorithm that Allstate used to price the policy because it's a completely different department. And finally, my linguistic disclaimer is that I'm French and deaf, so I apologize in advance for any misunderstanding or misuse of English.
It's okay. I think we can handle it. I appreciate those disclaimers. FYI, my own training was first and foremost as a statistical analyst and model builder, and I designed, built, and evaluated lots of different models on the social science side as well as on the business side. And so I'm hoping that my quantification and we used to call ourselves quants, but I think that's no longer, in vogue. So that's sort of what I bring to the panel. Before we begin, I want to help you understand a little bit more about what algorithms really are. Algorithms, the input that they use is obviously data, and few calculation methods and procedures are new when it comes to algorithms. But before we go anywhere, we should really begin with a definition of what is an algorithm. This is one that I kind of like to use, and it's just pretty simple in that an algorithm is really a step-by-step procedure for a calculation. So if you look at it from just a very clean mathematics perspective, right, it makes it pretty simple to think about. But that's not really the end of the story, because as we know, the explosion of data and the explosion of compute power has really changed where these algorithms are now being applied. Where they used to be once buried in in an academic paper, are now being applied very ubiquitously in ways that are not always transparent to everyone. And that's part of why we're having this panel today, because I think the more awareness we have to understanding what's possible and yet what is being done with the algorithms means that you really also have to have a bit of an understanding of statistics, and that is not, as our panelists can assure you, is not something that is widely understood. And it creates a little bit, that's where part of the human pushback comes from, is that our inability to really kind of think statistically, right? Or operate with a pure statistical approach, right? Is part of what makes us human, and it's also what makes using these algorithms a little bit more challenging than most of us would like to admit, okay? Not on this panel, but in other places. I had a lot of notes here that I think I'm going to dispense with at the moment. And I'd like to really kind of help you think about Google PageRank. And the reason I want you to think about Google PageRank is that it's one of the most successful algorithms that exists. It's incredibly widely deployed. We like to think we understand how it works, right? It was very transparent in its origination, and that's why it's called PageRank. But at the same time, it has changed very dramatically over time because its success depends on what it is that people want to have happen as a result of that algorithm, right? So when you put whatever information you do into your search box, you want it to come back with a result that satisfies you, as someone on one of the earlier panels just, made that distinction about satisfying a need, right? So its statistical power then was trained to go look at whether or not the results satisfied the user. And if it didn't satisfy the user, we needed to go look for other data to go figure out how to satisfy the user. And it has increasingly not, it's no longer as objective as it once was. It's now very personalized and very contextualized. It's using a lot more information than the information you put into the search box. And yet, we think we understand how Google works, right? How many of you think that you understand how search works? Just show of hands. Really, not many of you think that you understand how search works, but you all use it because it's part of how Google has, 75% market share. So with that in mind, I'd like to go to the first question, which is really to talk about this tension between objectivity and our sense of fairness that builds trust. So what it is that the relationships between statistical and social power as it influences the design and objectives for the algorithms that you're using in your work. Who wants to begin?
Can I maybe take us back a little bit?
Yeah,
Oh,
I was
please
going to
do.
do the same thing, so.
Why don't you go ahead?
Oh,
Yes, we're having more of a conversation that we were had continued before. So
I'm not going to lie. This is not our first
perfectly
combo.
fine. That's right.
I think it's really interesting to actually just start from the start with what is an algorithm. And you provided a really interesting definition that is technical. I come from this, from the vantage point of a sociologist, and I see algorithms as socio-technical. And part of how they've become interesting and why I think it's important for us as designers, and I use it as a broad category, and be talking about things like design and data and behavior at a design conference, is because it opens up space for us to interrogate what's happening in these rather sort of what we assume are highly computational, highly objective, neutral systems are in fact not just that. And so I think Nick Seaver does a lot of really great work using ethnography to understand and sort of communicate what are algorithms, and less concerned with what is an algorithm as a definition, but what are algorithms in practice. So how do people use algorithms, and how do algorithms rub off on people, I think is sort of more where I'm interested in thinking about spaces for entry for us to think about and talk about and better understand what is happening here, how do people understand how they do algorithms, who's building them. Spoiler alert, not just computer scientists are doing this. We engage with algorithms and sometimes game systems to get different responses. So we need to think about all of those intersections, both human and technical, to better understand all sorts of questions around trust that we'll get to, but who owns things, who's responsible or accountable when things don't go as intended, and what does transparency actually mean given the complexity of these exchanges? I'm not going to steal any more time. I think we're going to.
I'll add to what you. So I think it's great. So I would actually offer a slightly different perspective on algorithms, and this sort of goes back to some of the original work in cognitive psychology when people were trying to when computers were emerging and people were trying to look at, is a human being really just another, like a computer system, and, are we just information processors? So the original kind of definitions of algorithms and heuristics, or algorithms, was that an algorithm is really a problem-solving method. It's a step-by-step procedure to solve a problem. Multiplication, division, these are steps, if you have the information and you run the procedures, you get an answer. And true algorithms are the ones where you get the correct answer. In the real world, when we look at human beings, How do human beings solve problems? Well, there are many problems in life. There's a spectrum of problems. People here are familiar with the notion of wicked problems. There's well-defined problems on one end of the spectrum, where if I know all the information, I know the procedure, I can solve the problem. And then there are wicked problems. And there's a spectrum. If I want to figure out what's the fastest way to get from here to O'Hare, it's complex, but it ain't wicked. There is a way for Waze is pretty damn good. I can know most of the variables that are important. I can calculate things, and I can tell you this will take 33 minutes. But things change, yes, but it's pretty good. On the other hand, what is the right treatment, the best treatment for someone with stage 4 colon cancer who has actually gone through 3 rounds of treatment? Now what do you do? Let's even take a less dramatic example. Think about building computer systems that can play checkers versus chess versus Go. So just think about it as a spectrum of kind of, well-defined problems to well-defined problems to ill-defined problems and wicked problems. And really to solve wicked problems, you could never know all the information that you need. You don't know what information is relevant. And it's complex systems. And so both humans and systems rely on what people call heuristics. These are principles, rules of thumb, models. And models are hypotheses about what's important. So I wanted to broaden a little bit. Today we use algorithms for all of that, but if we just step back and we say, what are these things trying to do? They're actually trying to take data, turn it into information that helps solve a problem. But the way that actually works in the real world, it really depends on whether or not you're trying to figure out the next move in checkers versus how to get to O'Hare versus what's the right cancer treatment. And we should get under the hood a little bit about how it's done, because it is, when people hear machine learning, just one other thought, and then, is that they think it's just the machine. It isn't just the machine. It's never just the machine. So I think we'll hold off on that. We'll get into that.
Building on that and kind of circling back to the question you were asking, I think we could ask ourselves what it means to know what an algorithm does. And I'm reminded of an experience a while ago where it was asked of college student to draw a bike and explain the physics of a bike, and draw like a slice of a toilet and explain the physics of a toilet. And essentially, back in the day, and I don't think it would be much better today, if you ask a bachelor student to do that, you're going to realize that people who we don't really understand the physics of the things we use. But at the same time, we know how to interact with them. We know if I push here, that is going to happen. I don't understand how my car works. It sometimes does unpredictable things, but I'm reasonably confident that, okay, if I turn the wheel that way, this is going to happen. And so from that perspective, I think that one aspect is that algorithms, irrespective of their complexity, are just unfamiliar for now, and we don't have a frame of reference as to how we can interact with them. And as we move forward and we get more experience with them, and actually entirely irrespective of how fair or unfair or biased, those algorithms will just grow more familiar with them and get more used to, okay, if I do this, the algorithm will do that, and we'll build familiarity and trust in the system, irrespective of the level of understanding that we have of it and the level of trust and objectivity in the system.
I think, if I comment, I think what's interesting, I think we're going to start to get to some things we were talking about offline, is that I think, trust is a really, it's obviously a really critical experience and factor here, but it's interesting because it's important to understand how people develop trust and how much people need to know in order to trust something. So let me give you an example. Self-driving cars. Julia talked about self-driving cars. It's going to take a lot for me as a human being to trust a car at this stage of my life driving 75 miles an hour, yes, driving over the speed limit, on the highway, as opposed to, it's like, how will I get there? I think I could get there, but the first thing I want to know is, can you park the damn car without banging into the car behind me? So in that scenario, I don't really need to know all the algorithms. I need to know what you can do and how reliable you are and how should I relate to you as an entity, whatever this cognitive, I call them a cognitive system is. But on the other hand, if someone, I'll use a bit more like Ted's example, if someone says that, I get a message that I need to replace my water heater, I need to evaluate what are the intents behind that? Do I trust the organization? What data are they using? Are they actually good at it? Like, if Waze didn't save me time constantly, I wouldn't use Waze. So I've developed trust with that over time. So, but then again, I think about a lot of spectrums. So, but let's say you went to the doctor, and the doctor said, you have hypertension, and I think you should take this medication. Okay, this is not even about an algorithm. Everybody has a different level of criteria for whether or not they trust that physician's recommendations. Some people go home and they use Google and they use PubMed and they search and they go to get second opinions, third opinions, but some people will simply say, okay, when do I start? So I think you have to it's context, what's the level of risk, what's the level of importance, it's complexity, and it's also, there's human variation. People will I think you're right, Florent, is that people don't know how to relate to these systems, but even the people who want to understand them, it's still a black box. Many people don't want to, but we have to, I think that's actually one of the challenges for design, from my perspective, is actually to figure out how to provide the right level of transparency so that people can comprehend what they're engaging with, make good decisions about whether to trust it, and know how they want to relate to it. But we're really at the beginning of that journey. So.
Right, so the fact that we really are in early days of applying and extending the power of where these algorithms are being used says a lot about the fact that we don't really have yet all the metaphors. And part of it is we are just beginning to understand where and how to model the world in its fullness using the data that is now abundant and comes in such enormous forms, and its ability to be able to be integrated across systems is really a new phenomena, right? That I can take an image and have a machine interpret it as a face, or a machine tell me how far a distance is, right? Such that I know, oh, I don't really want to walk there, right? I want to ride there somehow, okay? So this information, someone asked earlier about whether or not we really need this data. We need data all the time, and we just aren't very conscious of how we need it or how we use it. But we're constantly trying to make, all of our behaviors are informed by information that we process in however way we process it. I may be, farsighted and not be able to know how far a distance is very well, and I can rely on some other tool to measure it for me. That's really what a lot of these algorithms do, is that they help you separate, define, match, mark, those are the activities of the algorithms. But the algorithms are not really determining the purpose. They're not the ones who are saying this is what's good or this is what's valuable. That's something that people are still interpreting and doing. So my question for you is that how is it that you're actually using what your own backgrounds are doing in your own knowledge base to help inform the use of algorithms in your organizations?
So I just wanted to circle back to a couple things that everyone's talked about and that you just sort of highlighted. I think when I think about this entire space, I think of two things, or three things. One, what is the system that we're talking about, and do we understand the parts of that system? because we're talking about a lot of data points and individuals, but systems exist beyond the individuals, and beyond choice architecture or the choices that we're presenting to individuals, and whether or not that they actually have a true choice to make, or whether that's sort of manufactured consent, or who gets to decide what is good for me. So that's all the system part that I think we should start not with, do we automate this, or is there a technological answer to digitize this, but what is the system, and is an algorithm desirable as an approach to understanding and optimizing the system? The second question I would ask, and this relates to trust and ethics, is can we be sure that the outcomes of that algorithm are good? Who decides what is good? And that gets to the data. So we're talking a lot about data, but have we done the soul searching required to be comfortable with the fact that algorithms to work as intended rely on unambiguous data? We need to know what's going in. So what is that data? Who's deciding what that data is? And do they understand it? What might be missing? What might be objective versus more subjective? And how might that be potentially reproducing inequalities that already exist, analog or whatever? The third component of that is, how are these, the outputs of algorithms being used by humans, and what humans get to participate in that decision-making process? I think we're sort of at the beginning of all of these questions, but from a step back perspective, certainly all of these things, and it goes back to Mark, what's the problem? And I think we need to start with, what is the problem that we're trying to solve, and what are the appropriate techniques to think about solving that problem? It might be fine if I want to, use Yelp to figure out where I want to eat based on people's ratings. Great. That's pretty low risk for me. Getting an automated vehicle to pick up my kids from school? I don't know. So we trying to alleviate poverty, or determining the distribution of employment insurance or public benefits. We need to start to ask a lot of questions and really slow down about what are the implications if we're not actually sure what the data is saying, in terms of what the data has, and how that might be just sort of automating inequalities that already exist in a system. So I think I don't have any answers to those things, but I think those are the questions we should be obsessed with.
And to that question of the use of the algorithm, obviously we're coming from a slightly different standpoint, I work for a private company, and I think that's something that we need to keep in mind, is that back in the day, you had the employee of the furnace building company that would come to your house, take a look, and say, hey, you should buy a new furnace. Now you have the algorithm of the furnace building company that's looking at your data and telling you, hey, you should buy a new furnace. And at the end of the day, an algorithm has been built by someone to answer a specific question with a specific purpose. And I think it would be, to the extent that someone can be unfair to step-by-step procedure, I think it would be unfair to demand of algorithms that they are more fair and objective than the people who have been building them.
So if I can add a little bit. So I want to make a little bit of a distinction that's been useful for me in this kind of conversation, which is, because we throw around the term data a lot, and we throw around the term information, but I've tried to, maybe because of my background in cognitive psychology and kind of a constructive perspective on human beings, for me, I make a real distinction between data and information. So data is, again, and this is a model. I can't get out of my own head, my own model. But data is, I think about it as kind of the raw bits. They're the kind of the traces of something in the world. But it's raw. It doesn't have meaning. It doesn't have context. I don't think human beings need data. I think human beings need information, and they need something else, because there's a difference between information and insight, which is some comprehension or something actionable, something that a discovery about the world that has some importance to me, that means something to me, which I can do something with it. I can, something fits together. So when I think about, I want to make that distinction, because for me it starts to contextualize what an algorithm does and what it doesn't do, and what humans do in the process. So maybe this is, look, I'm not a data scientist. I can't even play one on TV, but I can tell you, I want to tell you a story. As I worked for 7 years for a company called Endeca, which nobody here has ever heard of, but I would bet you that the vast majority of you have used Endeca's software. How many people have used Home Depot's website? How many people have used Barnes & Noble? Okay, you've all used Endeca. You don't know it. Do you ever use the search on Barnes & Noble? You ever use the search on Home Depot? You used Endeca. Endeca was, now that I'm at IBM, I tell people Endeca was like a baby Watson. So we actually, what we did is we took data, we indexed it, we took quantitative and qualitative data, we indexed it, we could summarize it, and then we could enable people to engage with it and learn things from it. We could help you find the right camera on B&H Photo. We could help you find the right dishwasher. We could help engineers find the right parts to repair the Boeing jet. So we built, my team, we designed and built hundreds of what I call discovery applications. People would come to us and they'd say, we have a problem. You know, our engineers at Ford or GM, they need to find the right parts for their cars, but it has to be the right price, it has to be with the right supplier, it's got to have all the right design characteristics, and so help us do that. We have 80 different systems, help us figure this out. And they'd say, here's all our data, go make it. And I'd say, whoa, whoa, whoa. I'd say, let's figure out what are the humans trying to do. And this gets back to something that came up in the other conversation, which is, the way I look at it is, what do people want to accomplish? What's important to them? You know, you could use jobs to be done, whatever it is, but the extra layer for me is what do they need to know in order to be successful at doing that and to achieve their goals? It's not what they think they need, it's what would, if they could discover something, how could that transform their action? So then, the other distinction, I'm going on a little bit, but the other distinction I would make is that we start to educate companies and say, we don't just want your data, which you have all this data, but some of it could be garbage, some of it could be irrelevant. We want information assets. So we would say, what data can we turn into meaningful information that is an asset that has some value for a human being? So I know people get very excited about the idea of massive amounts of data and let's just index it all. But you know what? It can often, yes, you can actually enable serendipitous discovery, but you also can make a system with a lot of noise and a lot of spurious correlations. So we have to find a balance. So when someone builds an algorithm, they have to start with the problem and they have to say, what data is relevant? There is a selection. I'll say one more thing and then I'll stop and we can maybe talk about how it happens. But there was a philosopher, Karl Popper, who he used to do an exercise in his classes and he would say, all right, everyone take out a piece of paper, write down all the facts you see. And everyone would kind of look at him like, no, write down all the facts you see. And they say, well, what's a fact? What, there are 4 people up here, there's chair. That's the point, is that there is no, it's always from a perspective. So human beings designing algorithms are making those selections about what data is important. If we create an algorithm that we think can actually show people based on real world evidence what are the likely outcomes for someone just like you with your medical condition with these 5 treatments and what's going to happen with you. What if that data was all gathered in the US? What if it was all white men? Now you're building something for China. It's like, it's the same problem that we have in every space. Is the data, is it relevant to the problem? Is it good data? And is it representative of what you're trying to solve? That's what's behind the scenes.
To this last point that you just made, I think it's also important to realize that none of what Mark's just described is something that just is a problem that that's new for us to solve, right? So you brought up the case of the white men trying to use that to diagnose disease. Well, unfortunately, for a long time in this country, clinical trials were only, you were only allowed to use white men for the trials for the most part, right? And so most of your drugs that you use today, and many of the biggest pharma drugs, the trials were all used, you know, and the dosage levels and everything else were just determined on a very homogeneous data set. And it has had enormous ripples as a result. And, you know, fast forward, none of what the computation systems that are doing today are doing anything different. All the data issues have to get corrected before you can actually see alternative results from the computations. And that's what we're beginning to, that's part of the age that we're in right now with digitalization. And I think that's part of where we're also starting to see this interconnection across systems, that we're able to find the holes in the data faster, because we can start to see, wait a second, it doesn't really apply for this narrow a population, and we can actually query the system in a faster way than anything that we were doing manually before. So to that point, I'd love to hear from either Sarah or Florent to, you know, tell us some of their experiences with how the systems are helping you understand where those holes are.
I just wanted to, of course, circle back again. It seems to be a theme.
It's a conversation.
Yeah.
Yes, that's
Just
exactly
to sort of amplify the importance of not just the holes. So what are we basing evidence on? And traditionally it's been around a very specific population set that is not generalizable. So, whoa, we better slow down there. But also, and this is just to echo what the first panel was talking about around the importance of having diversity at the table right from the problem framing discussion. What is the problem and how do we understand that? You can't have, you know, and frankly, if you look at tech as a space, there's a diversity problem. And so there's a lot of people building things who have been trained the same way and see the same way and are very similar. So when we, you know, are building from a point of similarity, often we're building based on the assumptions of ourselves. And that's a really dangerous and slippery way to build anything. So when I said in the beginning, you know, it's as important to understand who's doing the designing and what those decision points are as, you know, bias in, bias out is basically what I'm trying to get at. And so we need to be really careful about, and where I think the power of design really comes in here is to not just add what are the data points and what kind of data do we need, but what is the importance of design and the design choices that we're making in combination, and who is sitting at this table when we're having this discussion? Because, you know, we look now, and there's been some corrections, but, you know, it's not a surprise that most assistants, you know, virtual assistants in the market are highly feminized. And now we're trying to correct this. I love the comment of please and thank you, but what does it say when we think we can bark orders at a female voice? That women are deferential, and we build the assumptions of gender that are highly problematic into systems, and we learn to communicate with those. So we gotta sort of slow down and ask ourselves some really tough questions about who's at the table when we're making design decisions, and what are the implications of those?
So,
short answer, we don't really have or think about that problem. And I have kind of a little bit of an anecdote. My wife used to work in fraud analytics, and working in fraud analytics, she had interaction with people from Experian. And I don't know how many people in the room have heard the name Experian. Okay. So the one thing that kind of really struck her was that those employees of Experian who she met, I mean, in cocktail startup, drink and so on, and interact kind of casually with, every one of them was kind of, had a compulsion to tell her, we know everything about you. And not like boasting, but just, they were kind of feeling the weight of the revelation they had when they came to that company, and they were, oh, okay, we really know everything about everyone. And so, from that perspective, I would say, from the perspective of the private sector, broadly speaking, I think there might be situation where we have too little or too few data that would lead to behavior. I mean, analysis being biased, but my broad guess would be in the private sector, if anything, the issue is more with the amount of data that the private sector has that you don't really know, or we don't really know what they have, and how that data might be biased. I think it's more about that abundance of data than about any hole in the data, because even if you're unbanked or uninsured, you're leaving trails of data for this kind of company to follow.
Can you comment about how the nature of how your team is constructed at Allstate and how differently that's changed over time? So for example, I'm sitting with people who run behavioral science teams. You know, I can tell you 10 years ago, there weren't behavioral science teams. So that's a new entry into the marketplace. And so the question is, who are they actually interacting with in the model building activities? So just share a little bit about who's part of the wider team that you're interacting with.
Okay, I'll be very brief. For now, my team has 2.5 members because I'm sharing one with another team. So I have someone who is coming from UX research background, someone who was a former sociologist, and someone who is a data scientist and had a background in cognitive psychology. And so we really have a wide variety of background, and but the UX researcher and the sociologist have limited. I mean, from a layman's perspective, they're quantitatively knowledgeable, but from a data scientist perspective, they're very qualitative people. And so we really. And myself, like I said, my background is in economics, so I have some understanding of analytics, but definitely not at the level of our data scientists. And so we really try to interact with them more at like I said, how do you interact with the model? What is the model saying? And so to give a very quick anecdote is, I had an interaction with a data scientist who had built a model to share with our agent to understand the defection risk of our customer. Like, is a customer going to cancel their policy with Allstate? And so we wanted to display that information to the agent, and so the data scientist was showing me the model and saying me like, so we have those low risk people, medium risk people, high risk people. So low risk, put a green light, medium risk, orange light, and high risk, a red light. Okay, what just out of curiosity, what are the defection risk that we're talking about? Also, the low risk, they have about a 5% defection risk. The medium risk, they have about a 10% defection risk. And the high risk, they have about a 20% defection risk. And I tried to tell him, like, politely and gently, but you can't tell agent that if they have a red light that says high defection risk, that person is going to defect like 20% of the time. That's not what high defection risk means for them. And so from that perspective, we're not really working with the design of the algorithm. We are more, around the conversation that we've been having here, we're more talking about what is the meaning going into those algorithms, and what is the meaning coming out of those algorithms, and is that the correct, are those the correct ones?
Sure. So we have, you know, our design team, and we have people who are kind of multi-skilled, but they cover the spectrum of, you know, design research. You know, we actually, for us, content design, and actually a subset of that is actually really important. We talk about conversational design because it's about conversations with data, with information, as well as conversations with cognitive systems. And that's actually a new challenge to figure out how to structure the conversation so that it's meaningful. You know, how do you design, if you're designing an advisor, a cognitive advisor for someone with diabetes, that's a different conversation, and to help them manage their diet in the real world, that's a different conversation than, you know, I'm a pharmacist and I'm about to prescribe some medication and I need to know if there's an interaction between these two drugs. So it's just a different kind of conversation. So we have people on our team. We work very closely with data scientists. We work closely with domain experts. We work closely with the target users ideally from start to finish. We all know it's not an ideal world. Sometimes we get algorithms delivered to us and they say, what can you do with this? But when it's really working, what we start with is we do kind of ethnographic work and you know, we have the data scientists either come along with us and the developers so they can understand. We build mental models. You know, what's the cognitive work, the discovery work that people are doing, and how could we use cognitive capabilities that we have or that we might have in order to enrich or transform that process. So they have to be there because they have to, you know, they're the experts on actually what's feasible. You know, we can dream stuff up, but if they say, well, that's a great idea, but it'll take us 15 years to do it, and here's why. It's like, oh, okay, you know, we can't defy gravity. But it has to be, when it's really working, it's a really tight collaboration. You know, I'd say it's maybe heavy on, you know, we have a lot of people on our team, not by accident, that have PhDs, and not because, you know, we value just PhDs, but it's because we have people who, you know, I'm a clinical psychologist. It just so happened the people that we gravitate to, we have a cognitive developmental psychologist, another cognitive psychologist, a human factor psychologist. So, you know, when you think about what's needed, but even the people on our team who don't have those degrees, they are people who are really interested in behavior science and behavioral economics and human change. And it's, you know, in our domain, you know, in any domain that has to do with AI, you gotta understand discovery and cognitive. You just have to, and it has to be a minor if it's not your major. The people who it's their major, they add a lot of value to the team because they can bring kind of models to the table already. You know, you don't have to figure this out. We've learned a little bit about how people seek information or how people solve problems, or, you know, we can leverage that. So that's a little bit about our team.
I'm a very lean team of one. I'm the nudge unit in the OSC, although I don't work by myself. So like I said in the beginning, I work for a regulator, which basically means I work with a ton of really smart accountants and securities lawyers who couldn't be more different than me in training and thought process, which is a huge benefit. When I talked about diversity at the table, part of that is what types of problem finding and problem solutioning frameworks do we bring to the table, and how can we mash those up and cross-pollinate so that we fill in the holes. We de-risk each other through the process, and I think it's really important, and I'm delighted to hear you know, about the more qualitative components of understanding context before we define the problem and then therefore the solutions, because as we all probably understand is that people love to solution first, or hypothesis driven sort of decision making, where you refine your set of possibilities right from the get-go and then sort of throw them at the wall and test. Technically, you can do an A/B test for anything, and it could help you understand, you know, what the impact of those 5 intervention arms are relative to each other. But what if the 6th one didn't make it? Because you misidentified the problem. And so I think it's interesting that I'm the social scientist of one in my unit, but I definitely don't work alone. And it's really interesting, actually, and important and challenging to work with folks who start from rules-based decision-making. There's a rule, so individuals ought to follow that. We know that humans don't do those things. In fact, they mostly don't follow rules or break them or game them somehow. And it's really interesting to think about how do you put humans into that equation so that we understand what are unmet needs come back, and then how are we thinking about designing with users that we're designing for in ways that draw on how humans actually make decisions, not how we want them to make decisions. And then what is our role in helping? And I think it's really great, Mark, that you talked about information versus data. What's the context that we are, you know, what is the choice architecture that we are offering our users that actually don't hinge on their choices? They can make a free choice, but their probability of making the best choice for themselves is increased by virtue of of the architecture that we provide with them. They know best. We don't know best. We can bring the expertise in, but I don't know what it's like to have a chronic illness, and so we should be talking to people with chronic illnesses about that experience.
So we're running out of time, unfortunately. So I'd like to open it up to the audience for questions. I see a gentleman in the back with a hand raised. Wait, can we, somebody have a microphone coming? There it is. There you go.
Good morning. Thanks for the conversation. MIT Review a few issues ago had a whole issue dedicated to learning systems, and the big concern that data scientists have at MIT is these machines who make decisions very quickly and who learn based on the algorithms. There is no log file for them to understand how the decision was made. So we're putting more and more trust in systems to make decisions. And when, for example, the stock market had a dip, a very radical dip, they were trying to figure out why it was happening as it was happening on CNN, and they ended up just shutting the system down because they could not figure it out and they needed to stop the dip. So the big concern in the issue, and I want to ask all of you, is how do we know that these systems are making these decisions correctly if we don't understand how they're making the decisions? Because there's no agreed upon way to de-link the decision and understand all the things that happened. So it's just like a black box.
Right, so this is actually a very large topic, explainability. It is way bigger than the time we have, but maybe you have something quick you can say so we could take another question or two.
I can offer just a couple thoughts about learning. I think that actually learning is another thing we should talk about because that's another thing that's kind of mystical, about machine learning. And again, not a data scientist, can't play one on TV, but I know enough to be dangerous. So there are a couple ways that machines learn. And they are developing new approaches all the time. But there is supervised and unsupervised learning. So supervised learning is, imagine you wanted to find out, and I'm going to give you a real example. You want to find out, radiologists are looking at hundreds of images all the time. They're sitting in a dark room. They know nothing about the patient. They have no time to look in an electronic medical record. What's relevant to a radiologist? Well, if we just fed a lot of data into a machine would spit out garbage. So one way that you actually discover that is you get a bunch of representative radiologists, you pull out the medical records, and you have the humans take this data set and they annotate it. That's just to demystify. They annotate it. They say, this is important, this is what this is history, this is this, this is this, this is this. It's a laborious manual process today. Hopefully it'll get smarter over time. And then that's your training data set. And then you give the system other data and you say, match it to that. Use that as your guide so that you build a model. Okay, so that's supervised learning. Unsupervised learning is when you create a model and you say go and you start feeding it data. But there's still a human creating a model, but it's less. There's less human intervention. There is human intervention, but then the extra question is, what is the mechanism for learning over time? Because it's not always automatic. So, for example. If you ask Siri a question or Alexa a question, she's going to give you the same damn answer. I'm sorry, I have to say she because that's where it is today, but the system will give you the same answer. But so you have to look at each cognitive system and say, is it set up for, what is its learning mechanism? We work in Watson Health, for example, we work in a regulated environment. And while in some ideal universe, it might be nice to learn in real time, can you imagine what it would be like if we had thousands of physicians using a cognitive system and based on all of their decisions, we started just re-racking things? Like, maybe you're a horrible physician and you're making a wrong decision. So learning, this to me is one of the most critical problems in the world that we work in, and no one has solved it, which is, what's the right way to enable these systems to learn, and then how do we manage that? And in our world, in regulated environment, we actually have to have traceability. Yeah. So when the recommendations change, why did they change? We got to know it. So, but it's a big problem. Can't answer it in 3 minutes.
Right,
That was
so
perfect.
I think we're out of time. So,
We're getting the yank off.
yeah, we're getting yanked, so, sorry, folks. We're all available at lunch, so, and throughout the day, right? Some of us.